Hello everyone, this is day 9 of the Data Science Bootcamp. In the previous lecture, we started with the SQL. We installed SQL and we did basics of it. And today we will be moving forward with more functionalities of SQL. So as you can see on my screen, I have Workbench open. In the last lecture, we created a table, student table. We also manipulated the table. We made changes in the table. We updated the table. We deleted the table. And this was the last result that we have in our place. Now
The
let's
screen
start
is
with one
showing
thing.
that, right?
I am extremely sorry about that. Yeah, is my screen visible now?
Yes.
Cool. Okay. So in the last lecture, we created the school DB database. We created a student table and we inserted table. We made changes in the student table, and that was the last lecture. So going forward, we will continue with the new SQL operation. Okay. In order to use the school DB, first we have to do school DB. This is recap of the last lecture. Okay. Because we have multiple databases, system database, student database, and school database. Any doubt anywhere, do let me know. And what we are going to do, we are going to select star, that is all columns from student. Okay. And we are getting all the student that we inserted. The schema of this table is ID, name, age, grade, date of birth, and most of the date of birth column is empty. Okay. Let's start with getting a specific column. In order to get a specific column, it's very easy. Select column name from student from the table, and you only get the column. Cool. You want to get another column, you put a comma, you put grade, and you get two columns. If you want all the column, you select a star. I'll be skimming through this, assuming that most of the functionalities are known by you guys. If any doubt, let me know. I'll explain it in depth. Okay?
Okay.
Okay, cool. Now, one of the more important operation, which is where clause. This is exactly what query in SQL stands for. Like you want to filter out your data, and where plays a very, very crucial role. Okay? Where what I want to get, I want to get let's say grade of 10th. Okay, that has to be 10. Okay, from student. Okay, select star from student, select all column from student, where grade is 10. And you get all the grade which are 10 standard. Cool. Okay, let's do a notch. Does that work? Yeah, it does work. Now, not when you do a not filter, you get 11, 9, and all the grades which are not 10. Okay, now let's do one thing. Grade age greater than 16. Okay, what we are getting? We are getting student with all the ages of 16, above the ages of 16. Cool. I'll just do one thing. Just give me a minute. Just copy, paste from the docs and share it here. Now, what are the operations we can perform on where? So that we will check here. Um, what are the operations that we can perform? First is an equal operation, which is where age is equal to 16. You get all the details with the column age, whose age are 16. You'll get those. Not equal to is the opposite. Okay. Now, not equal to alternative, this is something that is also is equal to, but not equal to something that we use, which is because in programming languages also this is valid. Okay. Then we have greater than, then we have less than, then we have greater than equal to, less than equal to. Now, between is an important operator. Between is a range. Let's say you want to select where age is between 15 and 17. Okay. If you want to pass a list, let's say there are three conditions, and if you want to check, like if they are in 10th, 12th, or 9th standard, you only want to get those. Then you can do a matches in list. That is an in operator. You have to pass it in a tuple. It's not what you call it in tuple, but it is in circular bracket. That's how you pass it. Not in. You want to exclude certain item. Like is for pattern matching. Let's say you want to get all the name which start with A. Okay, with name starting with A, then A percentage. So you're understanding what exactly like is, right? Let's say there's a name all starts with A, and if you put a percentage, anything after A will be part of that result. Okay. Similarly, not like when not like percentage A, then this pattern should not match. Name ending with A should not come in the result. Okay. These are the few parameters that are helpful. So in order to, I'll share the notes after the lecture. But these are the parameters you don't have to remember between and, not in, like, less than equal to, greater than equal to, all the operator that you can perform. Cool. Any doubts anywhere? No, right?
No.
Okay. Now let's do one thing. Okay, what I'll do, I'll ask, and maybe Devesh, if you can share your screen, we will do SQL Bold together. Okay. Krish, also you do it by yourself. You solve one problem. After Krish will share the screens, Krish will solve one problem. Solve one problem. Okay. Let's get started. Devesh, are you sharing your screen? Okay, cool. Cool. Open SQL Bold. Hello. Did we lose him? I think we did.
Mhm. I think.
Yeah, I think Devesh is no longer in the call. Okay, Krish, if you can get started. Maybe you share your screen, and when he's back, we'll continue.
Hmm. No, is it visible?
Yeah, it is visible. Okay, first let's understand it. We have a database. The database is a table movies, and these are the columns. And on the right side, you have to perform the task. Cool. Now,
Yeah.
find title of each field.
Yeah. Okay.
That's it. You get the title of all the field. Director. I believe you already solved it, right? So, comma title, comma director. Okay. Okay. Excellent. Continue to next. What do I say? Exercise. Cool. Now, queries with constant. This is with where clause. As you can see, the operators that you can use between, not between, the same thing that we discussed.
Hmm.
Do you want to go through it, or directly jump into the exercise?
Oh, we can directly jump. That's
Okay, cool. Let's do that. Table. The query is find movie with a row ID of 6. It's a condition. And where? That's it. Okay. Find movies released in years between 2000 and 2010.
This is.
Hmm. Hmm.
Is it necessary to write in brackets?
No, it's not necessary. But when you are reading it, this is an operator and this is the
Mhm.
column, and these are the table. That's it. Okay. Not released in years. I'm not needed this.
In not
No,
in
between,
between.
no, no.
we
Scroll
can.
up, you can check the operator is not
Okay,
between. That's
not
it. You were
between.
supposed to just put not before the between. That's
Oh,
it.
okay.
See, SQL, I find it just like English. Select
Mhm.
this column from this table where it is not between this.
Not between this, between this.
It works. Okay. Find first five Pixar movies and the release date. Now, how do you query if it is a Pixar movie or not?
Mm. First of all, let's.
Let's see.
All of these are
What?
Pixar movies only.
I think so. Yeah. There's no such thing. Yeah. All of these are Pixar movies. Okay.
We have to find the
First.
first file.
Mhm. We did not go through this
Yes.
operator yet.
Mhm.
It's limit.
Oh yeah, limit. So
Are they asking for limit?
I think we can say between 1 to 5 ID also.
That is also. I think that's what they're asking. Let's do that. But IDs are not necessarily in this order.
Mm.
Do a
In
limit. Let's say if
sequence.
limit. Yeah. They're not always in sequence. Do a limit five. No. Limit just five. Just five. Just five. No equal to nothing. Yeah.
Okay, so they are asking for limit only.
Do a between one to five. I think is that that also would give you the same result.
ID.
Where ID. Where you have to put a
Mm.
where clause.
Wow.
It's
Okay,
working
that
good.
also works. Mm.
Cool. Nice. Yeah, Devish, you have joined. So I'll give a recap. So in this particular exercise, we went through the where clause. So the operators that we discussed in the, previously, all of them are mentioned and scroll down page, and this is what we perform. So when we have to find a row IDC equal to ID of 6, we did a where clause, and then here for that we used a between operator. Then in the third one, you used a not between operator. And the last time it was a limit operator that we did not discuss. But limit is, let's say if you want to limit from to a certain number, then it is limit. There are two operators, limit and offset. Offset is where you want to start, and limit is where you want to end. Cool? Okay. Divesh, if you can share your screen, we will move forward with the next exercise on your screen. Divesh, you there? Why do we keep losing?
The time of sharing screen, I think he is having some issue.
Yeah, I think his system sort of gives up, I believe. Well, let's not do it that way. Because you keep sharing your screen and we both will check.
Mm.
Okay. Chapter 3, scroll down. Same. Okay. These are the operators and we want to use it. We should valid and implementation. Okay, scroll down. Or do you want to go through it?
Yes, we will go through it while solving the questions like that. Wait,
Makes sense. Find all the Toy Story movies.
find out the first story movies. Okay, where title.
Hmm.
Put it in the screen.
The query incomplete. On every keystroke it runs it. So why it did not work? Title. Anyway, this will not work, but like I want to figure out this. So do a small t in the title. Oh yeah, Toy Story at least it came. But There's Toy Story 1, there's Toy Story 2. How do you capture this?
Mhm.
It's a pattern, right?
Yes. And capture or story and use like
Yeah, like if you want to use pattern. Instead of equal to, no, no, no. Like is an operator. Equal to is an operator. You replace an operator by an operator. And what's the pattern? It's
string or
Toy Story. At the end, it has to be percentage. See, you
Mhm.
got everything. Toy Story 1, Toy Story 2, Toy Story 3. Cool. Any doubts here?
No. Yeah.
Okay. The next one is easy. Find all movies directed by John uh, Lasseter, I believe. Nice.
Here we will
What
have
happened to
to
Nishant? Any idea? Is he well? And when I
yeah,
called him,
I don't think so. I haven't talked to him. Yesterday I talked with
okay.
so here we can simply use equal operator. I think so.
Yeah, we can use equal as well. So do a is operator is also fine instead of equal.
Is
Yeah, is also work.
okay, where director is this. Okay.
Mm. Equal to. Yes, go ahead, move forward. Find all movies and directors not directed by John Lasseter.
Then we can use the director not
Ah, that's it. Not.
not
No, not
equal
isn't.
to
Yeah, not equal to. Yep. Find all the Wally movies or wall pattern movies.
there's like again the like operator will come.
Sorry, come again.
I guess the use of like operator will come. Okay.
Yeah, yeah, yeah. Definitely.
Here is the wall. Uh,
Okay. Are you familiar with I like,
with
Krish? I like operator?
I like no.
Mhm. Okay, okay. We'll go through it after. There's an extra double quote at the end. Okay. Now you're doing this. This is key sensitive. Do a small a. Wall,
Where
put a small a anywhere, like
here
capital A with small a. Yeah. How is it working? It should not work. Oh, sorry. Use an I like. Oh my God. I like is case sensitive. What is the
I
problem?
like incomplete SQL.
I like, right? Where title. Oh, what's the problem here? Do a capital I like, or does it not support? I think this particular portal does not support it.
Maybe
Okay, cool. Now instead of percentage, do a star with like. Does that work? Do a star? No, it does not work. Only percentage is a while current. So keep doing such stuff so that you
hmm.
know. Okay, cool. Continue to next lecture.
Okay,
Next
till then,
exercise. Filtering and sorting query results.
to make an offset.
The limit has started just now. Do one thing, Krish. Move to the previous exercise where we already use limit. I think we'll check the solution where we already use limit. Not here. Previous. Nope. We did use limit, right?
Yeah, here.
Okay, click on the solutions. On the right side, read this task solution. No, 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 at the bottom, below the exercise. Yeah, click on it. Okay, click on it again. Click on it. The first five Pixar movie. Okay, click on it. Click on the solution again. Okay. Why? Okay, this is the logic that they have used. Find
Okay.
first five
Release.
Pixar and their
Release.
release year. Okay.
Okay.
But was it sorted by year? I think our solution is better one. Find first five Pixar movies and the release year. We found the first five Pixar movies and the respective
Hmm.
release year, not by the order of year.
Yeah.
Okay, cool. Continue to where we left. Now filtering and sorting per result. Same. Let's start with the exercise. If you are stuck, we'll come back to documentation.
This and the director process like alphabetical without duplicates.
Hmm.
So without duplicates means
Like that means without duplicates.
we have to use distinct operator like
Okay. Distinct on column character. Okay.
alphabetically.
So,
We will use order by.
hmm,
So order by in the where clause only, or it's a separate entity.
it's a separate entity. Order space 5.
Right column name.
Okay. Done. List the last four Pixar movies released, ordered from most recent to least.
Okay, so last four release. Then
Mhm.
we can go by
Most
years, I
recent
think.
to least. Yes.
And select year.
No, to select here. I mean, all the columns are fine. Put the filter on here.
Mhm. So we will use where clause.
Not needed. Order by should do it.
Uh,
Order by year. Do a descending. Okay.
I
Limit.
want the okay, then we will use that.
Limit 4.
Mhm.
Cool. Let's
Yeah.
go through the query again. Getting all the columns from the
Mhm.
table movie, ordering it by year because it needed the most recent. So that is the higher the value, the recent it is. And we want the first four movie, right? List the last four movie. We want the last four movie. So you did a limit 4.
Hmm.
Okay, cool. Now list first five Pixar movie sorted alphabetically. Let's see, you should do it by yourself. Cool. Next five Pixar movies sorted alphabetically. Next five,
Okay, then we have thing
5
I
to 10.
that.
Yes. Put it anywhere, it's fine.
How we will use offset.
Limit and offset, and we put a limit 5, limit 10. Limit. Yeah. Scroll up. Limit after offset. Okay. Okay. Limit 5, offset 5. Do a limit 5, offset 5. Not here. Put limit first and then after that put offset. Hmm.
So offset
Limit
5 means we are
start
starting
from
from
5. Start from 5.
okay.
Continue. And we are good.
Which is list of the Canadian cities and their population.
Populations. Mhm.
So we only select we'll use where close it's
Yeah,
not
of
unique
course. It's a filter.
where
Canadian cities. Cities in Canada.
city
No, country. Like it's a country. It's city in Canada. So on the country column.
oh sorry
Country is Canada or equal to Canada.
country in or like
Depends. Like we are using only a single value. So it can be either is or equal to. No, in when you want to have multiple values.
hmm,
So either use is or equal to Canada. Okay.
okay, what
There are
about
two
the
cities from Canada. Because we selected all the columns, so we got the
yeah,
population as well.
okay
Population is a column. Okay.
hmm,
Order all cities in United States by their latitude from north to south.
that's clear. What about the cities in the United States?
Hmm.
Yes.
United States.
First we go to United States.
Okay.
You have to order by then
By
latitude
latitude
from north to
from
south.
north to south. Now, north to south, I think I'm not very
I'm also
sure
not sure.
if
But
latitude will
let's
increase or decrease, but we'll alternate it. We'll use order by and you would use a DSC and that's it. No, ASC is not the right answer. So DSC. No, DE.
hmm, not D.
C. DESC. Descending. Yep. So descending is the right answer. So
No,
more the north it is, higher the yeah, that's the right answer. So higher the latitude, the northern it is. That is what I'm understanding.
but still it didn't
Mhm.
tag.
No,
Okay,
we solved the second one.
okay, my bad. I thought we are solving the first.
No. List all cities uh, west of Chicago, order from east to west. Now it's latitude. Oh, sorry, it's longitude now.
Mhm.
So let's solve it. Chicago is a sorry city. I mean it's a state, but in our column is a city. It's a city, yeah, it's a city. See, we have to list all the cities on the west of Chicago. Okay, so
Yeah.
the clause will be on the longitude, so not on
Okay.
Chicago. Get it? So query all of it and get the longitude of Chicago. What is the longitude of Chicago? 19, whatever, whatever.
Well, it
Scroll down
is.
at the bottom. Yeah, minus 87.
Okay.
Okay, in west of Chicago. So west is this side. I don't know if it increases or decreases. So do a filter on longitude greater than minus 87.
In where clause only.
Yeah, in where clause where
The
longitude
longitude.
greater than minus 87. Okay, we have listed all the cities. Okay, from west to east and order by uh, longitude. I think that also has to be longitude. BSC. What are we missing? What are we missing? Okay, do a less than minus 87. Geography is not that strong. Uh, are these cities west of Chicago? So what are latitude? These are latitude, right?
So it
And
is
these are
done. It
longitude.
was by AS
Oh,
ascending.
it's done.
Yeah.
Oh, okay. By default, it is ascending. So,
Yeah.
okay,
So you don't need to add ascending.
okay, it's worked, right?
Hmm.
Okay, cool. Let's check the solution for this. You there? Hello, Krish, can you hear me?
Yeah, yeah, yeah.
Yeah, check for the solution.
So
Oh, you went ahead.
where do
I
we
don't.
get that?
Um, move to previous and then come back here. No, no. Okay, cool. Solution.
Equal to Canada.
Okay, solution. Okay, order by latitude. Okay, exactly as our solution, right?
Hmm.
Okay. Now find two largest cities in Mexico by population. Easy. Do a select star. No, it is only taking city and longitude.
Okay. We have to find the largest city in Mexico.
Mexico. Two largest cities in Mexico.
We can sort by
Two.
where.
Sorry. Yeah. Where? We started where? Mexico. That's how we pronounce it.
Mexico.
The three. We want
Largest
top two.
city. And two largest, so we can order by
No
population.
order. You're limiting it, right?
Okay.
Top two.
Top two largest city, then first I think we should order by the population.
Yeah, yeah. Order by population is necessary, of course.
Mhm.
It has to be. It can't be ascending, right?
Yeah.
Okay. Cool. Now, if I want third and fourth largest city, third and fourth largest city, how do you do it?
We can do the offset.
Yeah, offset two. That's it. You'll only get one because there's no fourth entry. Cool.
Still, it didn't
Same.
solve
This.
yet.
Yeah, we did not see the last one. This is the third and fourth largest city by population, United States and their population.
So we will be in the country United States.
That should do it.
And it's, uh,
And they
third
want third and fourth largest city. Cool, awesome. We did it. Okay, let's
yeah.
move to next lecture. Oh, next exercise. Joins, one of the important part of SQL.
Hmm.
Any familiarity with joins previously?
Yeah, I have used, but not
Not an
like,
expert.
yeah, not too much familiar with it.
Okay. Okay. See, a relational database is, I mean, very useful because it creates relation. You don't have to write data again and again. It uses lesser columns. And join plays a very important part in this. You have a primary key, which is a foreign key to the other table. And then if you do a join, it creates a very big table. You don't have to store it in that way. You can store efficiently. But while querying, you can use join and do multiple operations. There are students and subjects. This student has this subject. You create a join and you can do it. If you write it yourself, then it will be very big column. Let's say Saurabh, Krish, Devesh, the three people. And Saurabh, Krish, Devesh, another column is subject. Then there is science, commerce, I don't know, science, geography, environment. So this will create three columns. Okay, instead of that, what I'll do, I'll create another table which is subject and I'll reference it to me, just me. ID of student, that is my ID, will be the foreign key of the what do I say? The primary key would be the foreign key of the students table. And so student table will have a limited data. The subject table will have a smaller set of data. When we put a join in it, then only we'll get multiple data. So you're understanding what I'm trying to explain?
Yeah.
Okay, cool. Let's start. Okay, let's go through this first. I think joins are important. So up to now, we have been working with a single table, but entity data in real world is often broken down into pieces and stored across multiple orthogonal tables using process known as normalization. What I just explained is called normalization.
Normalization. Yeah.
Okay, we'll not get into in depth explaining the boycott models and all that. That's something maybe you might have learned in your semester. Okay.
Yeah.
Data normalization is useful because it minimizes duplicated data in any single data table and allows for data in the database to grow independently of each other. That is, types of car engines can grow independent of each type of car. As a trade-off, queries get slightly more complex since they have to be able to find data from different parts of database, and performance issues can arise when working with many large tables. Yeah, that's true. In order to answer a question about an entity that has data spanning multiple tables in a normalized database, we need to learn how to create a query that can combine all that data and pull out exactly the information we needed. Just 1 minute. Cool. Multiple table queries and join. Tables that share information about a single entity need to have a primary key that identifies that the entity uniquely across the database. Clarity on the concept of primary key. It has to be a unique key, what do I say, value in the column so that an entity is identified. Okay, one key primary type is auto increment integer because they are space efficient, but it can also be string and hash value so long as it is unique. Usually nowadays, in NoSQL that you have used, that's especially MongoDB, you will see primary keys are hash. The IDs are hash ID,
Yeah.
and the same approach is now used in SQL as well, at least in our organization. When we are doing it, we don't put it in auto increment because it gives an idea to the user. Let's say if it is product/1, you get the product of ID 1. Now to hide it from the user, we use a hash key. A
Mm.
random string is generated and it is stored. So it acts as a primary key. So that's what they are explaining. Now, using the join clause in a query, we can combine raw data across two separate tables using the unique key. The first of the joins we will be introduced is the inner join. Okay,
Okay.
now they are making inner join. By default, I think default join is inner join. Okay, if you don't use inner join, if you just use join, it is inner join. Select column, another column from table, inner join to the another table. Now, where you are making the join? As I explained you, there were two tables, that is students and subjects. Now, student ID and the subject student ID should match. Then only it would be able to fetch all the details. Get it? So
Yeah.
what they are doing, they are making a join on a column, which is, primary key and foreign key relationship is entitled to that particular column. And then we, as usual, we do make our condition, and that is how it happened. Okay. Inner join is a process that matches row from the first table and second table, which have the same key as defined on. So inner join, if you are familiar with set theory, when it's inner join, only matched columns are given.
Mhm.
Let's say
Yeah,
ID is present on student, ID is present subject. If they're matching, then only will be given. If it is left join, then all the values from the left side of the table
that happened.
and the matched on the right side table. If it is right join, then all the tables from the right side of the table and only matched on the left side. And it is outer join, then all the tables, irrespective of if they are matching on. Cool. Okay, let's
Yeah.
start with the exercise. We have two tables, that is movies and box office. And where are you performing the join? It is on movie ID. See, movie ID is the foreign key, okay, which is tied to the movies table.
Hmm.
Okay, the primary key of the movie is the foreign key as a movie ID in the box office. So if you do a join, you will get a very big table.
Okay.
Get it? Okay, now you have a two table, you have to make a join on it, and you have to find the domestic and international sales for each movie.
So domestic and international sales for each movie.
That is all movie.
Okay. So from where will we start?
Okay, you are already
Start from
selected
movies.
star from movies.
Hmm.
Okay, select star from movies. Scroll up, and check for the what do I say?
Syntax
Check for the syntax. Yeah, column from column.
and
Okay,
another.
another column. In our case, we are selecting all the columns
Hmm.
from the table. We are making inner join other table. Where are we making inner join? We are making inner join on the on. Okay,
Understand?
inner join.
Okay.
Okay, so the second table will be inner join. Scroll down.
So here we will write inner join
Inner join. Yes, inner join on
on the
which table? On the
movie
other
table,
table,
like
which is box
box office
office.
table.
Okay,
So, okay.
okay. Now perform the inner join where?
Well,
On. Perform my bad. Perform the inner join on. When I meant where, I meant like on which ID. Okay,
so like
on,
it's on.
yeah, on. See, primary key and the foreign key. So scroll
Hmm.
down. It will be in our case on movie.id,
Okay.
movie.id equal to
Movie dot or underscore I.
movie dot. Movies. Sorry, it is movies. My bad. So which is table name on movies table of ID column
Okay.
equal to box office table of movie ID column. This
Hmm.
is where you are performing the join. That's it. Got it?
Okay. Yeah. So when we get like when we first
In
do
order to
the
make a
join.
join, first you have to have an idea which is the primary key and which is the foreign key to the other table. In
Hmm.
our case, movie ID is the foreign key to movies ID at the primary key ID. Get it right? If you do it yourself, just go to top, see Toy Story, movie ID 1. Now, if you want to find domestic and international sale, how would you find it on the box office table? Like through the naked eye, like by yourself, without using SQL query. At the top, you see Toy Story, you know, and what would be the domestic and international sales? The above table, movies table and box office table, do it yourself.
I didn't got the question like.
Now, I'm telling you, the first
Mhm.
movie, which is Toy Story, okay? I
Yeah.
want to find domestic and international sale. How do I find it?
Only for the
How would
Toy
you find
Story.
it? Only Toy Story.
Okay. And we can
Don't
use
write query. Don't write query. You do it yourself.
then we will find like here all the movie ID which have 111.
Yes, exactly. That's what we are doing. That is how we are making joins.
Hmm.
Get it? Toy Story's ID is one. Movie ID is
Yeah.
one. That means that is the box office collection. So box office collection is this. Okay. So this movie ID is a foreign key. Foreign key to the movies table at the column ID. That's what I
Yeah.
was saying. Okay. Let's move forward to the next exercise. Show the sales number for each movie that did better internationally rather than domestically. Okay. Okay.
Show the sales for each movie.
That means that international sales was better than domestic sales. I mean, I can think of
Yeah.
Dangal.
Hmm. International sales. So we will perform in the join only, right? In
So
this,
join, you have already performed. You have all the data.
yeah,
And it's a condition that the
where
international sale is greater than domestic sales.
we can directly compare two columns, or
Yeah, we can. I mean, that's not the best practice if you want to do it, but you can, in this case, you can do it. Okay, it is working. See, international sales greater than domestic. This will work for you. But as a part of best practice, when you're doing it, always use table name dot column name when multiple tables are involved. So when you are debugging later, because these are small queries, I mean, I have written
yeah,
queries which are 10,000 lines, and in order to debug those, you have to better you write column names. So in our case, it should be box office dot international column, box office dot domestic column. Let's say if you want to compare across two different tables, then this is an handy solution. Okay, got it?
got it.
Okay, list all the movies by the rating in descending order.
So then we don't want this where
We don't
clause.
need the where, yeah.
We can list all the movies by the rating. We can direct order by on the rating.
Yes, we can. We can do that. Done, right?
Yeah, done. But one thing I
Okay.
didn't get, it was
Mhm. What did you not get?
like when we only do the inner join,
Mhm.
it results in like this duplicate, or like there are a lot of number one IDs, there are a lot of rows.
Because you're not specified on what column you're doing it. Say, so number of time, I mean, don't think of this. So it tries to render the query. Anyways,
Mhm.
it's an incomplete query. You're doing an inner join. And by
Okay.
default, if let's say if a query is identified by themselves, then they make a join. You know, get it?
Okay.
If you don't specify an on keyword, it by default makes a join on a particular, because SQL do have a knowledge what is a foreign key and what is a primary key, and they mix a join that way.
Okay. Got it. Got
Now it's an outer join.
it. Mhm.
Outer join will get all the data from both the table,
Mhm.
but inner join was performed only on the data that were present in both the tables. Did you get the difference? Okay, cool. Do you want to right away jump into the exercise or you want to go through documentation?
Um, we can quickly go through. I think we can skim through
Okay.
it.
Depending on how we want to analyze the data, inner join we used in last session might not be sufficient because the resulting table only contains data that belongs in both the tables.
Both tables.
The
Yeah.
inner join will give you data in both the tables. Now you want data which are not present in both the tables that are also part of the query. As a asymmetric data, which can easily happen when data is entered in different stages, then you would have to have left join, right join, full join, instead to ensure that data unit is not left out. Left, you want to specify when you select a column, the first table is your left, the join when you make that is your right table. So if you
Hmm.
want to have the left of the data, you do use a left join. If you want to have all the data of the right side, you do a right join.
Right
If you
join.
want to get all the data, you do a full join, irrespective of whatever it is. Okay. The on condition is necessary, like on what particular column you want to run this. What do I say? Make this join.
Hmm.
Clear? Let's jump into the exercise quickly. Okay, you have two tables, that is buildings and employees, and find the list of all buildings that have employees.
All buildings that have employees.
Hmm.
So we will perform
Not
the
all the
outer join.
building has employees.
Simply we will perform the outer join. Yeah. Please.
Yeah, okay, try it. Okay. On buildings dot building name. You're doing employees. No, it has to be buildings and employees. So you're making join. If you're checking, select staff or employees, outer join employees. Same table, right? How to use building, outer join and building. It is just building. Cancel it. And there is a problem, which is no, there's no need of S. Oh yeah, there is S. Sorry. Right.
Hmm.
Okay, remove the on part. Okay, select star from employees, outer join buildings. Okay, I think it does not support outer join. Scroll up, scroll down. Somewhere it must be written.
Oh, full
Um,
join, I think.
full join, yeah, full join. The full join. Somewhere it is written. You did a full join. Okay, now do it on
Now on the employees dot building.
employees dot building name or building, sorry, and buildings dot building name. Like, however you want to do it. Remove the full, just put join there. I think it does not support full join. I think it's a question. Scroll up. Somewhere it is written. Okay. Uh,
or we can say
this it's fine. Scroll down.
but
Let's continue with our logic. Our logic is that list all the buildings that have employees.
employees. Okay,
Not all
so we
buildings
not
has
need.
employees. If you see the scroll down, there might be building where the employees are not present. Not here, the query result.
Where it is.
Scroll down.
This is building,
Hmm.
and this is
Find list of all buildings that have employees. Okay, let me solve it. Okay, share the link. Cool, I'm sharing my screen now. Okay, we want to perform outer join. We have two tables. Cool. Find list of all the buildings that have employees. List of all the buildings that have employees. Okay, let's start from employees. Okay, let's perform. Find list of all the buildings that have employees. Okay, I want to perform left join on left join, that is buildings, left joins on buildings on employees dot building name. Okay, it's capital B plus dot building name. Oh, it's building. Okay. Employees dot building, employees dot building equal to buildings dot building name. Huh. Now we have performed the join list of all the buildings that have employees. 1E years employed. Okay. 2E, 1E, 2E, 3E. I think 2E does not have employee. Full. So I
yeah,
want full join.
right.
If I do a full join, I'll get tables from, okay, full join is not supported in this particular system. Now when I do a 2E, okay, you only want building. Okay. So what I'll do, building. So that's exactly what we're doing. Find list of, do it want distinct or what?
Mm,
To
maybe. Mm,
distinct. Oh, it needed distinct. Okay. Find list of all buildings that are employees. Cool. Uh, nice. I will share the query with you. We'll check the solution later. Find list of the buildings and their capacity. So list of all building and capacity would be here. Building, comma, capacity. Now what is the problem? Find list of all buildings. But in our case, 2E has the capacity of 20. May not need this building and building dot capacity. Select star from Find list of all buildings and their capacity. This is building and capacity. So let's start from buildings to do it, right? Okay. List all buildings and their distinct employee. All building and their distinct employee.
Distinct employees.
Include empty building as well. Include empty building, right? List all buildings and the
Employees
distinct
will be
distinct employee roles. Okay. Okay. So I want building. I want role. Now there has to be an which is empty. So what I did, find was just fine. Okay, list of buildings that are distinct employee. So all
distinct.
the building, even if I perform, but I want to include empty buildings, which is 2E. I think will not work, but let me put distinct on it. Distinct role group by building. Group by building. Group by employees of building. Oh, we did it or what? Oh no, sorry. Employees dot building. We have from employees do a join on buildings, which employees on buildings, building dot name. Okay, list all buildings and the distinct employee roles. Okay, if I do a distinct one, mm, maybe this is something. Okay, but distinct building and role, and I want right join has to be left to join. Full join, full join does not support here. So in our case, this 2E also has to come with an empty. Okay,
Mm-hmm.
let's put the solution. Okay, left join. We need to left join as well, right?
Yeah.
From buildings. Oh, I get it. I get it. It does not support right join. It only supports left join. Since our browser SQL is somewhat limited, only left join is supported in the exercise below. Now I get it. Okay. This was our this thing. We did a join. In our case, it was employee, right? All we have to do was and okay, do a left join. It only supports left join.
Hmm.
Building from buildings. Where are the empty this thing, building and role. Okay, employees dot building. This is buildings dot building. And this should work. I don't think this has anything to do with. Okay, distinct on building and role.
Maybe the building name of the column name is building name. Or,
Sorry, building employees dot building. Employees dot building, and this is
no,
building name.
in the select distinct building. So the name of the column is building underscore name. So does it matter?
Okay. Got it. Even I was wondering where did I make a mistake? Okay. Distinct role, and then you get it. So we did a left because only left gen is supported. All solution was right. Cool. Do you want to do it yourself again?
Yeah, I think I will.
Okay. Do it. Let's do one thing. Let's do two more, and then we will call it a day.
Wait a minute. Where did it went? Visible, right?
Yeah, it is visible.
Okay. So this we did. We are performing only left join.
We can only perform left gen.
Left join, then the right, the name of on buildings. On
It's building name.
distinct.
Cool. Awesome.
To find the list of all buildings of the capacity. So let's start from it also done.
Now the
So
last one.
here in this case, like this is the primary key, right? For this table
Hmm. No,
and for
building is a foreign key. I think building name is the primary key on the left side of the table. Because
this is
building is a
primary
foreign key.
and okay. So this is
The
foreign key.
primary key has to be unique across the table.
Okay, so here it is duplicated. One.
Yeah, it is foreign key. So
Okay,
foreign, like
right, it's fine.
the
Mhm.
Bargav table is the buildings table.
Hmm. So this is building table. This is the primary key,
Hmm. Hmm.
and this is foreign. And if we do the left join, then we can only see the left side of the table. You, as you mentioned, the
No, no,
data.
no, 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 no. When you do a left join, all the data from the left join, irrespective of they are matching or not, they'll be shown. They'll be maybe, let's say the other column would be null. Okay.
Mhm.
So when you do left, all the data of the left. When you do a right, all the data of the right. When you do a full, all the data of the left and right both. And when you do an inner join, only match data is done. Get it?
Okay, okay. Take it away. So here we have to select the buildings and the distinct employee.
In each building. Okay.
Suppose
So we want all the data from the left side.
so distinct of the building name and the capacity. Sorry, the role.
Hmm. Hmm.
Okay, and the left join on employees.
That's correct.
The employees.
Where are you putting the join on?
On the buildings dot building name and employees
Correct.
dot building.
Yeah, that's not building. Yeah, that should do it. Awesome. Okay, let's continue to the next exercise. Okay, it's a short note. We are going to talk about null. It's always goes to reduce possibility of the null. Okay. Uh, scroll down, scroll down. Okay, we are using same employee build formula, but we hired a few more people who have been assigned. So null is an empty value, as you understand. Certain
Hmm.
columns can be null. While you are making join, if they are not present, then they will be set as null. As you can see in our previous exercise, the building
Yeah.
2E was empty because it did not have any
Yeah.
employee, so it was treated as null. Okay, scroll
Hmm.
down. Let's finish with the exercise.
What does it say? Find the name and role of all employees who have not been assigned to a building.
Building.
Okay, so this is they are not assigned to building and it is
Yeah,
two.
they are not assigned to a building.
Hmm.
So I don't think you need to join for this particular table.
Yeah, even I do think it
Yeah,
will
just do
be
it on employees.
on the which column we will say
Yep. Is null.
is null.
Where yeah, where building is null.
Exactly. Is employees, right?
At what time do you have to leave?
Oh, I will leave around 9:50, I guess.
Okay, cool. We have ample amount of time. And you got it. First, the name of the building that hold no employees.
And the name of the building that hold no employees. We have to find the building name and that has no employee. It has no
Scroll
name.
down. Okay, that has no employees. Yeah, got it. So make a join where uh,
Mhm.
building name is empty. Not building name is empty, but yeah, you make a
Null
join, then
or
we'll look at yeah.
from start and we'll have to join
Remember,
it
we
on.
can only perform left join. So start with building. Don't start with employees. See, we want all the column from buildings, right? So put buildings there and employees later. That hold no employees. Okay. There are two buildings that does not hold any employees.
Mhm. So one W and two E.
Yeah, do a where clause.
So building name is
No,
null or
building name will be present, right? Building is none, role is none, name is none, could be anything.
okay. So is null.
Yeah, is null.
Mhm.
Yeah, it could be anything. And as a part of best practice, it has to be employees dot role.
Okay, so in the employees table we are referring to the role.
We are referring to role. So, cool.
Okay.
Continue. Any doubts here? No, right?
No.
Okay. Queries with expression. Mhm. Okay. If you want to support an expression, multiplication, addition, all of these are supported. There is something called absolute value, you know. So shall we go through it, or do you want to right away jump into the exercise?
Okay, I think we will continue this in the next because I need to, I mean, more.
Cool. It's up to you. Okay, so we will be continuing with this in the next lecture, and I wanted to cover what transaction is, but that's fine. We'll continue in the next lecture.
Yeah, I
And
need to
that's it.
like study more about the inner join and the left join. I
Okay,
need to
okay.
grasp more on this, understand more of
Okay,
it.
okay. I'll once again repeat it for you. Left join, right join, outer join, inner join. There are different join. Table one, table two. If you are, let's say, my thumbs are matching, okay, only they are matching on this query. Let's say they are present in both the table. You know this value. If I do a inner join, only the value which are common across both the table, they'll be shown. Okay.
Yeah,
If I do a left join, the table that I mentioned on the left side, all that data will be shown, and the table that has mentioned that is matched on the right side, only that particular row would be fetched. Okay. Similarly for right join, only all the data from the right side, and only match data on the left side, which is my thumb. Okay. Now for outer join, that is full join, all the data would be matched, all the data would be shown. There would be empty columns for, let's say, 8 elements, and only two rows will have data, filled data across both the tables. So that is your full join. Get it? Just an overview. And yeah, you should practice this. Joins are very necessary. Joins you have to grasp it.
yeah.
Okay. Oh, Krish, thank you for your time. See you in the next lecture, and we'll continue with SQ. Okay. See you. Bye.
Okay, bye.